Pluto is not the frozen dead world we once thought it to be. NASA's New Horizons probe has uncovered something fascinating happening beneath its icy surface. Something scientists never expected. Could active volcanoes exist on this far-off dwarf planet? And if so, what would this suggest about the possibility of life on Pluto? In 2015, New Horizons sent back images of Pluto that astonished scientists. Less than a year later, continued analysis revealed even more interesting facts about what was happening on this cold, dark world. Pluto might be far more dynamic and geologically active than we ever had considered. This video explores what the images revealed, how Pluto's mysterious mountains defy expectations, and what all this could mean for the future of exploring the outer solar system. When New Horizons flew by Pluto in 2015, it returned the first close-up images ever taken of the distant dwarf planet. These images completely revised everything we thought we knew about Pluto. Instead of being a static frozen rock at the edge of the solar system, Pluto appeared to have an active surface with strange geological formations. The biggest surprise came in the form of two giant mountains, Right Mons and Picard Mons. Both mountain features rise kilometers above Pluto's surface, far higher than would be expected for a world with such low gravitational pull. Interestingly, these mountains did not show signs of impact craters, implying they had formed relatively recently, geologically speaking. On a world as cold as Pluto, with an average surface temperature of minus 240 degrees Celsius, such young features raise an exciting question. Could Pluto still be geologically active? Right Mons and Picard Mons are the centerpieces of Pluto's surface, located on the left side of Pluto's iconic heart-shaped feature, Sputnik Planitia. These formations are likely ice volcanoes, a phenomenon known as cryovolcanism. Cryovolcanoes erupt with water, ammonia, and methane, rather than molten rock we see in Earth's volcanoes. Right Mons is about 150 kilometers wide, and its summit rises about 5 kilometers high. Picard Mons is even taller, nearly 7 kilometers, and is 225 kilometers across. Although Pluto is only 1/6 the size of Earth, these volcanoes are comparable in volume to Mauna Loa, one of the largest volcanoes on Earth. Here's where it gets even more interesting. Pluto does not have any nearby moons or planets exerting tidal forces that would generate enough heat for these eruptions. Additionally, Pluto's core is too small to contain enough radioactive material to drive such activity. The big question is, where is the heat coming from to fuel these icy volcanoes? To understand how these volcanoes form, we need to figure out what is producing enough heat to drive cryovolcanic activity on Pluto. On Earth, volcanism is driven by either the heat generated by radioactive decay deep within a planet's core, or the movement of tectonic plates. For some of Jupiter and Saturn's moons, like Io and Enceladus, volcanism is produced by gravitational tugging from their giant host planets. However, none of these explanations work for Pluto. None of its neighbors in the Kuiper belt are large enough to create substantial gravitational heating. And Pluto's rocky core isn't rich enough in radioactive material to generate the necessary internal heat. Yet, Right Mons and Picard Mons are thought to have formed as recently as 2 billion years ago, a blink of an eye in geological terms. The leading theory is that Pluto still retains some of the heat generated during its formation. Billions of years ago, when Pluto and the other planets were coming together, rock and ice collided and merged in great impacts, releasing tremendous amounts of heat. Some of that heat may still be retained in Pluto's interior today. But that's not all. Even more intriguing is the possibility of a subsurface ocean beneath Pluto's icy crust, with heat leaking slowly to the surface, fueling the cryovolcanic activity. The idea that Pluto could have a liquid ocean beneath its frozen shell is not far-fetched. In fact, several icy worlds in the outer solar system, such as Jupiter's moon, Europa, and Saturn's Enceladus, are believed to harbor oceans beneath their icy crusts. Kept warm form by residual heat from the planet's formation and gravitational interactions. On Pluto, evidence for such an ocean includes the fact that the material around Wright Mons and Picard Mons is mostly water ice. This is unusual because the rest of Pluto's surface is dominated by nitrogen and methane ice, both of which form more readily in its ultra-cold environment. The presence of water ice suggests recent cryovolcanic eruptions that spread water from beneath Pluto's surface onto its frozen exterior. If Pluto does have a subsurface ocean, an exciting possibility arises. Could this ocean be hosting life? One of the key ingredients for life, as we understand it, is liquid water. While Pluto's surface is far too cold to support life, a warm liquid ocean beneath the ice could provide the right conditions for microbial life to thrive. For scientists, this is a tantalizing prospect. Life could plausibly exist in one of the unlikeliest regions of the solar system. What makes Pluto's ice volcanoes so fascinating is that nothing quite like them has been observed elsewhere in the solar system. Although cryovolcanism has been seen on moons like Enceladus, where geysers shoot icy material into space, the volcanoes on Pluto are different. They don't simply eject icy material, they seem to construct large mountainous structures that are kept in flux as the surface reshapes itself. Scientists theorize that Pluto's ice volcanoes may have formed from multiple eruptions over long periods, with each eruption layering water ice into towering formations. The number of volcanic domes appears to be interconnected in some regions, forming an extended frozen surface that changes. Like other landscapes on Pluto, cryovolcanism appears to be unique to Pluto and has not been observed on other planets or moons. Since New Horizons only observed Pluto for a brief time during its flyby, it's unclear whether this cryovolcanism is still active or has become dormant. However, the discovery of fresh geological activity on Pluto raises the exciting possibility that its icy surface may still be active today. The presence of cryovolcanism on Pluto suggests that its interior may not be as cold as we initially thought, and there could be liquid water beneath its surface. Where there is liquid water, the possibility of life increases. Microbial life forms could survive in a subsurface ocean if geothermal heat provides enough energy. Although the chance for life on Pluto is speculative, the discovery of recent volcanism on such a distant and frigid world presents a revolutionary new understanding of the outer solar system. If life exists on Pluto, it would challenge our assumptions about where life can survive in the universe. Cryovolcanism on Pluto is a recent discovery, and new images and data from New Horizons are still being analyzed. Scientists remain fascinated by this enigmatic dwarf planet, and future missions to the outer solar system may unlock many of Pluto's secrets, and perhaps its hidden ocean. Pluto has proven to be much more dynamic and diverse than previously believed. Its towering ice volcanoes and the possibility of a subsurface ocean offer huge surprises in our understanding of the Kuiper Belt and the far reaches of the solar system.